Hey guys, HackerSploit here, back again with another video. Welcome back to the Web App Pentesting series. In this video, we're going to be taking a deep dive into HTTP headers and methods. So in the previous video, we got an introduction to HTTP, and we also explored, the various HTTP headers that are included in requests and responses. So in this video, we'll be taking a deep dive into HTTP headers, methods, as well as status codes, but we'll primarily be focusing on the headers and then obviously on the methods, which are equally or probably the most important in this video. So the target system that I'm going to be using is Metasploitable 2. Now I know it's an old system, but the reason I'm using it is twofold. Firstly, this is the only system that I had on hand that I could use to explain a few things. And secondly, it has a very good collection of web apps here, regardless of their age. One of them is an actual web dev directory, which is going to be very, very important in this case, or for this particular video. So you can follow along if you want to. I'm really just going over concepts and also a few practical techniques here, especially with curl. So the two tools that I'll be using are going to be curl and Burp Suite for obvious reasons. I'll primarily be using curl because it's much easier, and we'll be using Burp Suite to analyze requests and responses and to get an understanding of the various HTTP request headers and response headers, right? So what I'll do is let me just fire up Burp Suite, and I have the Foxy Proxy add-on configured for Firefox. For those of you not familiar with it, it's a great add-on for Firefox that allows you to switch between proxies. So again, in the case of, in my case, I've set up a Burp proxy option, which is essentially localhost, so 127.0.0.1 on port 8080, so that all my traffic is redirected to Burp Suite. So let me just fire up Burp Suite here. So next and start Burp. And I also want to configure a few UI options. Now I will be covering how to use Burp Suite and pretty much all the features in its own video, but for now, just bear with me. I'll be explaining, various aspects as I move on. So, user options, display, I think that's good enough. So I've just increased the font size so that you can actually see my requests. So head over into proxy, make sure intercept is on, that's done. And we can try and make a GET request, right? So I'll just refresh this page here. So I'm making a GET request, I'm just refreshing, so I'm making a GET request for the same page or the root of the web server. So in order to modify requests and then of course send them and then view the responses, we can send this to the repeater or just use Control and R. And hopefully you can see that, or the text is large enough for you to see. Hopefully it is. Right, so this is a typical, request header, or sorry, this is a typical HTTP request. And, at the top, the first line contains your HTTP method. So in this case, we have a GET request. So, the various HTTP methods available are GET, POST, PUT, DELETE, options, trace, and a couple of others that I'll be highlighting. So you have your HTTP method. You then have the actual resource path, or the path to the resource. You can see it's the root of the web server. And then the HTTP protocol version, which is HTTP 1.1. So let's take a look at the host option, right? So the host header. So the host header is again used to specify the host name, right? Now, why are you specifying the host name, or why is the host name specified? Well, that's because in certain cases, a web server could be hosting more than one website on the same IP address. And again, I don't have an example here, but that will actually change. In this case, because there's really only one web server running on the target system, the IP address or the domain of that particular, server is going to be specified as the host. User agent, that specifies, the browser that the client is using. And again, as I mentioned in the previous video, this is very useful in, essentially providing this information is very useful for the server, because it then knows how to parse the data, or the request, and what type of data to send in regards to the actual browser that the target is using. So is it a desktop browser? Is it a mobile browser? Does the web page need to be responsive? Stuff like that. And again, one really quick tip that I wanted to give you is, in most cases, you'll usually see the Mozilla option specified here. That is pretty much the de facto. Whenever you make a request, the user agent will always contain Mozilla. That is that was one of the remnants when it was one of the remnants left over when the actual user agent header was created. And at that time, the browser that was the most popular was Netscape. So again, this is just something that's left over. It hasn't been fixed, but again, you can always obtain your actual browser, your browser information there. So in my case, it's Firefox 78.0. You then have accept. Right now, accept is used to specify what type of content the client will accept. And this is in regards to file formats for both the actual web page itself as well as images. So in this case, the client is essentially saying, hey, Mr. Server, I'm making a GET request for this particular web page or resource, and the only format that I'll be able to accept based on the fact that I'm using Mozilla is HTML, XHTML or XML, XML, and in terms of images, WebP or images in the WebP format, right? We then have the accept language. That's fairly simple to understand. That is essentially the language that the actual browser is requesting. So if I install Mozilla Firefox with a different language, maybe French, for example, then the accept language option or header will be modified to reflect that accordingly. And then the web page will respond, the web server will respond with a web page that is in French. Although in some cases that might not be the case, if the actual web application or web server, does not know how to respond or does not know how to actually switch languages. But again, in most cases, it's fairly common that it actually, translates roughly the actual website or the web content into the language that the client is requesting. You then have accept encoding. Accept encoding is something that you'll probably see on both sides, but it's primarily within the actual HTTP requests, and it's a request header by default. So accept encoding is used to specify the type of encoding that the client accepts based on the browser. So in this case, the encoding supported is gzip and deflate. We'll explore that when we get there in depth. A lot of you are asking me what connection close means. Now, this is both an HTTP request and response header. So you might be asking, why is it specified there? I mean, why is it saying connection close? Well, that's not really for the HTTP session. That's for the TCP connection. So what the client is saying here, because this is the actual request, is it's telling the server, after I make the request, I want you to close or, stop the TCP connection between us. And then whenever I need another resource, I'll make another GET request. So that's really what it's used to specify. You then have your cookie. Again, cookie, that just contains the cookie that will be sent to the server or that the server sent, for the client to use. And in this case, you can see that when we refresh the page, you can see that we have a PHP session ID cookie there. We'll get into cookies and sessions in the next video, and how that affects how data is or how requests are sent and processed. You then have your cache control. Now, cache control, I don't think I want to get into it now, but it's both a request and response header. What this is used to do is it specifies the actual caching option for the server in this case. And in the case of a response, in case it's part of a response header, it's essentially used to specify the actual cache, the caching option for the client. So that'll make sense in a couple of seconds. And then, of course, you have upgrade in secure requests. That just is used to, again, it specifies whether or not the browser wants to upgrade upgrade from HTTP to HTTPS. So it's set to 1, which means yes. So if the server supports or has an SSL certificate, then it'll automatically, the client is saying, I want you to upgrade my insecure request if I make one into HTTPS. And of course, I'll probably make a video on HTTPS, and a lot of you mentioned I didn't mention or didn't cover HTTP 2.0. Those are things that you'll only understand if you understand this. So I need to cover this first. Okay, so those are request headers. I'll send that. You then have your response headers. These are fairly simple to understand. So, at the top here, the first line, you have the HTTP protocol version. You then get your status code. In this case, it's saying 200 OK. So that means that the resource we are looking for exists, but we're just trying to access the root of the web server. So that actually shouldn't be an issue. You then have the server. The server header essentially tells you the server version or software that is set up or that is again processing the requests. So in this case, it's Apache 2.2.8. And in this case, it gives us the operating system banner. So we know that the target is running Ubuntu. And it also tells us, in this case, whether WebDAV has been configured. And we can see that is the case. We then have the X powered by header. This just tells you what a server-side language is processing your requests. So in this case, PHP 5.2.4, which I believe is vulnerable to a command injection vulnerability. We'll probably also explore that. That's going to be a good demonstration of how to exploit server-side languages. Okay, so we then have content length. Content length is used to specify the length of the message, of the body rather. So this right over here, so that the client knows how much data is being sent, and so that no data is lost, right? You then have content type. Again, in this case, text HTML. It's telling the client, hey, I'm sending over text HTML, and I know that you support it because you told me within your accept header that you support text HTML. Fairly simple to understand. All right, so those are, your request and response headers. Now, as I said, I'll be covering the other ones as we move along, but those are probably the most important one. One of the ones that isn't highlighted here that I wanted to highlight is the pragma response header. So let me see if I can demonstrate that really quickly. So I'll just get rid of this, of that session or tab within the repeater and head over into proxy. Let me just drop that. Probably under PHP my admin. So what I'll do here is intercept and let's make a request. Okay, so we don't have that here. So I'll send that to the repeater. And yeah, we'll just go ahead with that request and I'll send it over. Does this contain pragma? No, it doesn't contain that there. But essentially, the pragma response header tells the client not to store the response within the browser cache. So that's very, very important. That's really all that I wanted to highlight in regards to the actual response headers. Okay, so let's take a look at status codes before we move to methods, because methods is where things will start getting interesting, especially in this video. So status codes are essentially used to tell you, and this is pertinent to responses. They tell you whether or not your request was successful. So if I make a GET request for a resource, and what I'll do again here is let me get rid of that, and I'll drop that, and let's go back here. Right, and let's say I want to make a request for the actual WebDAV directory here. I'll send that to repeater. So you can see I'm making a GET request for the DAV directory, okay? If I send that, you can see it responds with HTTP 1.1200, okay? So that means that the resource was found. Now, if I look for another resource that doesn't exist on the web server, maybe, like some file.txt, and I send that, you can see it's going to say it provides us with a 404 not found status code. So let me explain status codes. Status codes range from 100 to 500, all right? So 100 is informational status codes. You then have your 200 status codes. These are, used to tell you whether or not your request was successful. And it's not just pertinent to GET requests, it's also pertinent to PUT requests, which we'll actually explore. We then have your 300 status codes. 300 are for redirection, which we actually saw. So again, that will essentially tell you whether you're being redirected. We have different 300 status codes. For example, 301 is moved permanently. So that essentially redirects you to the new location of the resource that you're trying to locate. You then have your 400 status code, which again is used to, this is really down to a request error made by the client. So that means there's something wrong on my end, that I'm making a request for something that probably doesn't exist. And it, again, so for example, 404 tells you that the resource is not found. We then have 401, which is unauthorized, which tells you that there was an authentication failure, which is, that's really pertinent in the case of a post request where we are trying to log in, for example. You then have your 403 forbidden status code. That is when you're trying to access a directory that you have been denied access to on the server side. So for example, if I configure an Apache web server to deny access to a particular directory and only allow access to a specific IP, and I try and access it, then I'll get a 4 or 3 forbidden status code. And then of course you have your 500 status codes. These are errors on the server side. So whenever you see a 500 server response code, that tells you that there's something wrong on the server side. So examples of this would be your 500 internal server error. So if you get a 500 response, if you get a 500 response code, that tells you that there's an internal server error, probably a misconfiguration of sorts. You then have your 503 status code, which tells you that the service is unavailable. That means that the web server is not responding correctly, or it may even be brute forced. Who knows? But yeah, they're fairly simple to understand. Now, the thing that you need to understand the most are your actual methods, and that's really what I want to highlight in this video, right? And the way I'll do it is with curl. And the reason for that will actually make sense in a couple of seconds. So I'll just disable that there, and I'll just disable the burp proxy there. Okay, so let me open up my terminal here. So how do you use curl? Well, if you want to learn how to use curl, it's a very, very powerful tool that can actually, it can do whatever burp does. And in my case, it's even easier to do it without burp or with curl, right? So you can open up the help menu here. So, I can say curl help. It'll give you various options, typical options that you are likely to use, like the verbose option, which I used in the previous video. You can output a request into a file, very, very important. You can also include protocol response headers in the output. We're not going to explore that right now. And then, of course, you can use the D option to submit HTTP post data. Now, the command that the option that I'm looking for specifically in this case is the X option, which many of you might be familiar with. So I'll open up the curl, the man pages for the curl utility here. Let me just zoom in. And I'll just grep for that particular option. So grep E, and that is hyphen uppercase X, hit enter. All right, so you can see that the X option is allows you to essentially perform a request and specify the method that you'd like to perform the request with. So that's what we're going to be doing. So for example, if I wanted to make a GET request, to the actual web server, and I'm trying to essentially view the contents of a web page or a resource, I can say curl. I can then say X, and then specify the actual method. So get, and then I'll put that in quotation marks. I then specify the actual server IP or domain, and in this case, it's just going to be the IP address of the Metasploitable 2 target. So I can make a GET request for the root of the web server. Right, so I'll hit enter, and you can see it displays what we're able to get on the web within the web browser, right? So fairly simple to understand. I can also use the verbose option, so V, to actually get the actual response here. So it'll actually it'll actually provide me with the response headers here, or the entire response. So you can see HTTP 1.1 200 OK, and we get pretty much what we were able to get with Burp Suite. And it also displays the actual body, right, of the response here, or the web page content for that matter. So that's how to make a GET request. I can also do this for other, directories or files that are on the web server. So for example, I can access the dav directory here, hit enter. You can see I'm making a GET request for the dav directory. That's fine. No use agent information is specified or needs to be specified there. And you can see right over here, let me actually highlight something important. You can see that when we make a request with curl, the accept request header is set to null, which means that it'll accept. It's not specifying any formats in regards to what curl can accept, and that's because again, in this case, curl wants both the request and the response headers displayed, as well as the actual body, of the actual response. So you can see that. If we take a look at the response, yeah, that's what I wanted to display. It's actually not displaying the actual response that I wanted, but we can say get dav. It should actually display the fact that dav is enabled. It should actually have a response header that actually tells you that that dav is actually configured. So let me just try that out here. Let me enable burp with, so I'll say web dav, send this to the repeater, and let me just send that. It actually doesn't do that. That's interesting. Very, very interesting. Okay, so that makes sense. Okay, yeah. So that makes sense. We'll get to this page in a second, right? So yeah, I'll actually go. I actually know why it's not responding with that. So that's making a GET request. Now let's explore some of the other HTTP methods available, right? So we have your GET request, you have a PUT request, you also have a POST request, you have your head request, or your head method. So you have GET, POST, head, trace, option, PUT, delete. And let me explain what each of these does. So GET, again, is used to request for a resource. You then have POST, which is used to perform a specific option like sending login data. Head is essentially works like GET. However, instead of actually displaying the actual response body or the body of the response, it will only display the response headers or the actual response itself. You then have your trace method, which again is used for diagnostics. We'll get into that in a second. You then have options, very, very important. The options method is used to obtain the HTTP methods that are available for a specific path or resource. You then have PUT, which is used to upload or put a specific file on a resource or a specific file or resource onto the server. So that's used for uploading. You then have the delete method, which is used to delete a resource on the server. So let's explore all of these one by one. We've taken a look at GET requests. The one that I want to highlight here is the head method, right? So again, I can just use curl and the X option, and I can use the head right over here, the head method there, specify the actual address of the web server, so 10.10.10.30, and for example, dav, and we'll also enable verbose output. So you can see what's happened here is I've essentially made a request with the head method, and that again works very similarly to your GET request, right? And in this case, you can see that it's saying setting a custom HTTP method to head with X, so the request may not work. That's perfectly fine. So again, this is very similar to your the actual GET method. The only thing is it doesn't display the content of the web page, right? And in this case, you can see that it's actually given us a redirect, so moved permanently, which again is fine. And the reason for that is because we didn't specify the / there. So there we are. Now it's saying HTTP 1.1 200 OK. So it's not displaying the content of the web page. And again, we can actually take a look at this with burp. So if I say head, right, and send that, you can see that it doesn't. We get the response, but it doesn't display the actual response itself or the content of the web page, right? So there you are. So it's very similar to your GET request, but it's only useful if you're trying to only analyze the response and not get the entire content of the web page or the actual resource that you're trying to access. You then have a few other options which I can probably highlight with burp. The one that I'm interested in now is trace, right? And that's used for diagnostic information. So I'll send that, and you can see that it's going to respond. So it'll tell you HTTP 1.1 200 OK. But we are looking for the actual trace here. So this just displays diagnostic information pertinent to the actual request and the way the actual server responds. So in this case, you can see trace dav HTTP 1.1. It then specifies the host, user agent, and of course accept. And if we do this with curl, you'll actually see something. It should display more information. So I'll just say trace here. And what was I looking for here? Yeah, there we are. So this is actually displaying the content that I wanted to display. So again, so transfer encoding, this is just diagnostic information. Transfer encoding, chunked content type, message, HTTP. So yeah, that's the trace method. You then have a few others. One of them is the options method, which is very, very important, because the options method essentially is used to obtain the HTTP methods that are available for a specific path or resource. So if I wanted to know what methods are available for maybe the root of the web server, so I can get rid of the dav directory there and I say options. So curl x options, and let's hit enter. It should actually display them, which is weird. It's curl x options, HTTP. Yeah, that's perfectly fine. That's the root of the web server. Is it displaying that here? It should actually display that. Let's try that with Burp. I just want to see options. There we are. That looks fine. And let's make a request for the root of the web server. So send, and it should actually display that what methods are supported within this directory. But I think that's because it's the root of the web server. So I'll say dav, hit send. Okay, so now it's actually displaying the actual methods that are allowed for this particular directory, right? So when we're trying to identify the methods that are allowed, we're, as a pen tester or a web app pen tester, you're really looking for interesting ones like post, delete, which is very dangerous. It means that within this directory, within the dav directory, I can actually delete files. And then it's not displaying put, which is very important, but put can also be, again, in some cases, it may not display the put method, but it really doesn't mean that we can't upload a file. It all comes down to testing, right? So you have delete, trace, which we know, prop find, copy, move. So this particular dav directory allows us to do pretty much anything we want in regards to, uploading data or sending data. Downloading or rather deleting data, moving it or copying it, etc. Now, why am I using the WebDAV directory? Because WebDAV is set up for this specific use case, right? WebDAV is used to share documents or files, in the format of a web server, right? So it works very closely to an HTTP file server, and that again is another example that I could have used. So you might be asking yourself, well, what can we do with all of this? We know that it supports all of these methods. How can we, as an attacker, take advantage of this? Well, let's say we wanted to actually upload or put a file into the dav directory, because it supports, post, but it's not saying put here, but we can essentially test that, with curl. So let's try that out, right? So the reason I like curl is because in the case of actually testing uploads, you can use you can use a really cool functionality that comes along with it. So I'll say 10, 10, 10, 30, and then in the dav directory, I can specify that I want to upload a file, right? So I can say upload and then file, and then specify the file that I would like to upload, right? So I can say, for example, user share web shells. Do we have PHP web shells here? Yeah, there we are. So we can upload a reverse shell if we want, but let's try backdoor. Let's try and upload the backdoor. So I can say upload file php backdoor.php, hit enter, and there we are. So we get a 201 status code, which I mentioned previously. 201 means that the put request was successful. So you can see the resource dav php backdoor.php has been created. So this vulnerability is is really a misconfigured web server vulnerability, in that the directory has not been configured to only allow methods that are secure. And typically with a WebDAV directory, there is going to be a form of authentication enabled, so you just can't access a WebDAV directory. But we've been able to upload it. So I'll head over into Metasploitable here. Let me just disable the proxy there. So you can see it's uploaded. I'll just refresh it, and if we try and execute it, you can see we have a PHP backdoor on the system. So I can enter a command like for example id. So the output will probably be www.data. So there we are. We can perform command injection. Now we can upload a file, do whatever we want. So that's just a basic PHP backdoor. What if we want to delete it? Because remember, if we go back into Burp here, into the repeater, you can see that the actual delete method is actually enabled, right, or available. So we can actually delete that particular PHP backdoor with curl. So I can say curl And then because we want to delete a specific file and not upload it, I'm just going to modify this request here. And we can essentially say, we can use the curl x option here, curl x, and we're now going to say delete. So the method is delete, and we can then say HTTP 10.10.10.30 dev, and then the name of the file, which is php backdoor.php, right? So let's see if this is successful. So I'll just hit enter. We don't get an output primarily because I didn't use the verbose option. But if we refresh the actual directory here, you can see that PHP backdoor has been deleted, right? So you get the idea. This is a very good vulnerability that I like using to showcase the power of methods and why they're so important to understand as a pen tester or as a bug bounty hunter. So always make sure that you actually test and see what the actual supported methods or allowed methods for a particular resource or directory. And this is not just limited to directories. It's also it is also applicable to files or individual files. So always be sure to essentially use the options method and test and see what the allowed HTTP methods are. Okay. Right, so that was a very, very simple example that, again, hopefully demonstrated this. As I said, I've not explored post, in this particular video, but that's something that will become relevant when we talk about authentication. And yeah, so again, this is going to conclude this video. Hopefully, you've been able to get a better understanding of headers as well as status, the various status codes that you'll typically find within responses, as well as HTTP methods. So again, you can utilize Burp Suite if you want, or you can use curl, which I personally like. And again, I like using Burp because I can see the response clearly. And yeah, go ahead and test out the various methods and see how the web server responds. Try and find resources, try and identify, how you can utilize the various methods. I've already showcased quite a few of them. For example, we already covered get, post to a certain degree, head, trace, options, put, and delete. So we've pretty much covered all of them. So yeah, that's going to conclude this video. Yeah, we've actually been going for a very long time. So thank you for sticking through this. Hopefully you've learned a lot about this now. So that's going to be it for this video. If you have any comments or feedback or questions, leave them in the comment section down below. If you want to reach out to me, you can do so via my Twitter profile. The link to that is in the description, or you can join our Discord server. The link to that is also in the description. With that being said, that's going to be it for me, and I'll be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Dafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.